Okay, welcome to this session on enterprise architecture. We're going to look at how is that we would build a simple IT application. I'll run you through a sample scenario that we'll take up, and we'll look at how we take the scenario from the concept to what the client wants to actually building an application. We are currently not focusing on any technology. We are purely focusing on what is the architecture stack going to look like. I'll start with discussing a sample scenario which is in the banking domain. We're looking at creating an online application similarly to what most of you would have as a banking account. We're looking at how we could access this account online by using a simple UI which is Internet Explorer based. So we're looking at developing a web application, giving access to clients so that they could log on to their account, interact with it, probably do a funds transfer and something like that. Now, what's the first thing that you think we would require to start building this application? The first thing would be the screen via which clients would interact with the account, and that's the first thing that I'm looking at building. To illustrate what I'm trying to do is I have here a simple client that I'm talking about. I'm going to denote this as Internet Explorer, IE for short. Now this is the client that we're talking about that customers are going to interact with to ultimately go and access their account details. Now obviously we would expect some kind of web content to open up on this client, and we would expect the content to be hosted on some server. So that's the next box that we would require in our architecture stack. We would need to connect to this server so that I could stream content, pure HTML content into the browser that would be displayed to the client. Now, when I talk about server, we need to ask ourselves what type of server would we need here. Let's talk about a normal server that you typically access on your local area network. Now that's a server that typically runs on a protocol called as TCP/IP, and when you open up such a shared server, you would expect a set of folders and a set of files to pop up. However, to stream web content or HTML content to the client, we would typically look at not creating a folder structure for the client to view, but looking at nice little web pages with a lot of color and animation and text. And for that, we would need to send an HTTP request so that we stream HTML data back to the client browser. For that to happen, a normal server would not do the job, and hence what we would need is something called as a web server. What a web server would do is allow me to stream pure HTML content back to the client rather than having a set of files and folders. And that's why I would need a web server and not a normal server like a TCP server where I would go and host the banking application that I would have. I'm talking about a simple scenario now of authenticating the user against some kind of user ID and password. So I would need an ID, I would need a password which I would accept, and that's what I would send to the web server to check whether this is a valid user on the network or not. There are multiple areas where I could have written this business logic to check whether this is a valid user or not. One way is to do it at this end on the client. Had I done it on the client, it would have been too much processing load for the client. One job that the client is doing is displaying the browser, displaying the web application to you. The second thing it would be doing is also checking for the credentials. It would also not be a very safe and secure thing to write business logic to validate the user on the client end, which is why we would preferably shift that to the server end. So on the web server is where I'm going to go and host my business logic, so that the moment the username and password is accepted, this is where it would get transferred, the user gets authenticated, and you are in the banking website. Now there's another drawback of putting the business logic on the web server. The problem with this is the web server again is stressed, it's doing too much, it's also responding to HTTP requests, it's sending HTML content onto the browser, and it's also processing user ID and passwords. So the solution is not going to be a very fast solution. It's not going to be a performance intelligent solution. And that's the reason we would prefer segregating this responsibility and giving it to another box so that the web server is preferably doing just one job of responding to the client. So what I'm going to do now is introduce another box to this architecture stack. And this is where I'm going to host the business logic of doing the user ID and password authentication. The benefit of this now is we've got proper segregation of responsibilities where the client takes the data, the web server responds with HTML content depending on what options the user clicks on, and the business logic is processed on a separate server. The primary role of this server being to accept user ID passwords, authenticate users and get them into the system. What is that I need to do to convert this machine into a web server? Very simple. I just need to install some kind of software that would make this box behave like a web server and make it respond to HTTP requests. One software I could install is Internet Information Server. Another software I could install is probably a Tomcat server. So any kind of web server is what I would look at. Install the software onto this box and the box starts behaving like a web server. One primary thing that we need to look at here is don't think of a server as a hardware component. It's simply a software component because I could take any machine, install a server based OS on it and it would start behaving like a server. And that's the reason installing either of these softwares would make this machine behave like a web server. What is that I would need to do to this box so that I could deploy my business logic there for checking user credentials? Again, a simple software installation required here, which is either COM+ or softwares like JBoss is what we would need at this end to convert this box into something we know as an application server. Okay, what is an application server and how is it different from a normal server on your network? An application server is meant to collectively host business logic components so that multiple users can connect to it. So typically if I write code to check for a user ID and a password validation, I would typically write it from a single user perspective, assuming that one user would go and access that code. What we're doing here by deploying it in an application server, it automatically scales up to n number of users trying to get themselves authenticated without you as a developer having to do anything special to scale up the object creation or the number of users that are going to connect to the code block you've written. Now obviously when we have data that is flowing to the system in terms of user ID and password authentication, we need to store that data somewhere, and that's where we need some kind of storage mechanism to come in. So that's where I'm going to introduce a database server. We also just discussed that a server is actually a software component, which means that if I need to convert this box into a database server, all I need to do is install either of these softwares. So I go into an Oracle installation, or I go into a SQL Server installation. What you have now is proper segregation of responsibilities. This kind of architecture is typically called an n-tier architecture. And why are we saying n-tier? Because I've got one tier which typically is taking care of presenting data to the user, that's the presentation logic. I've got another tier which is typically accepting user inputs, throwing data back to the client. I've got a middle tier here which is processing my business logic, and I've got a database tier here which is taking care of the data persistence. All the user ID passwords that are coming into the banking system is basically stored and retrieved from that data store. Since we've got segregation of responsibility into multiple tiers with solutions deployed on multiple servers, it's an n-tier application, which would mean it could scale up with another set of servers in between, and hence n is what we refer to any number of servers that you'd like to use to segregate responsibility here. Again, if you look at this architecture, it's something that automates a business from an end-to-end perspective. So it's taking the entire manual register that you would have in the bank for tracking users and putting it online. What we're trying to do is look at how an existing business is functioning and completely automate the way the business is doing what it does today in a manual mode. What we're aiming at doing is taking a business online, which means we're trying to automate what an enterprise is doing, and an enterprise would mean a business or an organization, which is why such an architecture is also referred to as an enterprise architecture, which means it completely automates and provides an end-to-end solution for taking a business and the way it works and putting it online. That's all in terms of what a simple enterprise architecture would do for you. Thank you.